Hey everybody, this is Mr. Longo, and in this video we are going to cover rational and polynomial inequalities. And I'm going to tell you the steps for doing this. Step 1 is to factor. Now, fair warning, all of the examples in this video are going to be in factored form already just to save time. But if they are not in factored form, it is your job to put them in factored form. Step 2, your X-Intercepts. Basically, what you're going to do is you're going to solve and find your X-Intercepts, which means set your parentheses with x equal to 0 and solve. If it's a rational function, just the numerator needs to be done for that. And then you're going to put the appropriate bubble. Remember, if it is less than or greater than, you're going to do an open circle. And if it's less than or equal to or greater than or equal to, you are going to do a closed circle. Okay? For vertical asymptotes, so if this is a rational function that has a denominator, just like in graphing, that is an asymptote, which means that cannot happen. So vertical asymptotes will always have an open circle. And then you're just going to test your intervals in between. And I'm going to show you a little trick to do that to make it easier for you. Okay? So, this is an example of a polynomial inequality because there's no denominator. So step 1 is to factor. Done. Step 2, find your X-intercepts. So we're going to have 3 of them. We're going to have x plus 1 equals 0, so x equals a negative 1. We're going to set that equal to 0 and get x equals 3. And we're going to set that equal to 0, and we're going to get x equals a negative 4. Okay? So now, this is greater than. So we're going to have open circles. We're going to plot these guys in order. So we have a negative 4 is going to be furthest to the left. And we're going to have a negative 1. And we're going to have a positive 3. Now, they don't have to be perfectly spaced or anything like that because this is just for us to test. So, how do you test? Well, you have to test all 4 regions. So that means anything less than a negative 4, anything in between a negative 4 and a negative 1, anything between a negative 1 and a 3, and then anything above 3. Now, you get to pick which ones you want to do. But then, you're going to plug it in. Now, what you can do is you can actually find the number, or I'm going to show you a little shortcut. Okay? So for this, I'm going to use x equals a negative 5. For my in-between, I'm going to use x equals negative 2. In between negative 1 and 3, the easiest is always to use 0 if you can. And then anything above, I'm just going to use x equals 4. So try to keep your numbers manageable. But then all you're going to do is plug them in. But here comes the shortcut part. So we have a negative 5 plus 1 times a negative 5 minus 3 times a negative 5 plus 4 squared. All I did was plug the numbers into the original inequality. And you could, like I said, find that number. If you want, you can say that x is equal to whatever and work it all out. But here's a little shortcut. Negative 5 plus 1 is going to be a negative number. Negative 5 minus 3 is going to be a negative number. And negative 5 plus 4 is a negative number squared is going to turn into a positive number. So a negative times a positive is going to be positive. So is a positive number greater than 0? Yes, it is. So this guy is true. Okay? So if you would rather do the numbers, you can go ahead and do the numbers. But if you like that little shortcut, go for it. You would do the same thing here. So you would have a negative 2 plus 1 times a negative 2 minus 3 and a negative 2 plus 4 squared. And this is going to give you a negative times a negative times a positive, which is still going to be positive. So this location is true. And I think you understand what I'm doing here. So if you want, pause the video and try the next two parts on your own and see what you get. All right, 0 plus 1 is going to give you a positive. 0 minus 3 is going to give you a negative. And 0 plus 4 squared is going to give you a positive. A positive times a positive is a negative. That is not greater than 0, so that is false. And then for the last section, you have x's above 3, so I picked 4. 4 plus 1 is going to be a positive. 4 minus 3 is still positive, and anything squared is going to be positive. So positive times a positive times a positive is positive, so it's true. So how do you write your final answer? Well, the way we write our final answer with these inequalities is in interval notation. So I want you to remember that this arrow pointing to the left is negative infinity, and this guy is positive infinity, and we're going to use interval notation. So it is true from negative infinity to negative 4. So we're going to have negative infinity to negative 4, close parentheses, union with, it is true between negative 4 and negative 1. And then it is false here, so we're not going to put anything for that guy. And then it is true from 3 to infinity. Okay? That's how you write your final answer. And that's it. Okay? So, this next example, you pretty much do the exact same way for the tests and everything. But the setup is just a little bit different. For your X-Intercepts, again, we're already in factored form. Our X-Intercepts are the solutions to the numerator. So we're going to have x equals a negative 2, and we're going to have x equals 3. Now our vertical asymptotes is when we set the denominator equal to 0. We're going to have an x equals 1, and we're going to have an x equals a negative 1. Now remember from the steps I said above, since vertical asymptotes don't take place in terms of, shall we say, an actual solution, those will always be an open circle. Okay, so the farthest to the left is a negative 2. Since it says less than or equal to, we are going to put a closed circle, and that's going to be our negative 2. Next up, we have a negative 1. That is going to be an open circle because vertical asymptotes will always be open circle. We're going to have a 1. And then we have another X-intercept, which is 3, and that guy will be a closed circle. And now you've got 5 different areas to test. Now again, it doesn't matter what numbers you want to pick. I like to try to keep them simple. So for the purpose of this video, I'm going to test a negative 3. And in between a negative 2 and a negative 1, you don't have a lot of options, so try negative 1.5. Between negative 1 and 1, I'm going to use 0. 1 and 3, I'm going to use 2. And anything above, I'm going to use 4. So what I would like you to do is pause this video and see if you can find out the rest of this answer. And we'll see what happens, okay? Give it a shot. Okay. So for the furthest to the left, we're going to plug in a negative 3 into this. Okay, so negative 3 plus 2 is a negative. Negative 3 minus 3 is a negative. Over, we're going to have a negative 3 minus 1, which is negative. And a negative 3 plus 1 is a negative, but it is squared. Okay, so it's a negative squared that will turn positive. So that's going to give us a negative times a negative over a negative times a positive. That's going to be negative. Okay, so is that less than or equal to 0? Yes, it is. So this guy is true. So that's what you should have done. So if you plug in a negative 1.5, you're going to have a positive times a negative over a negative times a positive, because, again, negative squared. A negative divided by a negative is positive. So this guy is false. Next section, plug in a 0. 0 plus 2 is positive. 0 minus 3 is negative. 0 minus 1 is a negative. And 0 plus 1 squared is a positive, which is going to give you a negative divided by a negative, which is positive. It is also false here. When you plug in a 2, 2 plus 2 is positive. 2 minus 3 is a negative. Over 2 minus 1 is a positive. And of course, anything squared is positive. Negative divided by a positive is negative, so this part is true. Last test is the 4. 4 plus 2 is positive. 4 minus 3 is also positive. Over 4 minus 1 is positive, and anything squared is positive, so this is going to be positive. So for this guy, you have a false statement. So your final answer should be written with interval notation or just your true sections. So it's true from negative infinity to a negative 2, square bracket because it is included. That's less than or equal to. Union. And then we are true from a positive 1 to 3. And that's it. Okay, so that's this video on polynomial and rational function inequalities. This is Longo, and I'm out. See you, bye.